Hi everyone. Today I want to do something a little bit different. Today I want to bring the forefront of scientific research to you guys. What I'm going to do every month or 2 months or so is take a look at one of the most influential scientific papers that has just come out. So this is cutting edge research, what's actually going on now, and then try and break it down for you guys so you can understand what scientists are currently investing their time in doing, what is getting people excited. So today I've chosen a paper that was published in Nature a short while ago, and the title, and you can find, I'll send you the link at the bottom of my video where you can actually find this paper for yourselves, but it's called Quenching of Star Formation from a Lack of Inflowing Gas to Galaxies. So not the most catchy of titles, but this is indeed a real scientific paper, and what I'm going to do now is explain exactly what it is that they did and the conclusions that they're drawn. For those of you who are interested perhaps in a scientific career, this is the kind of stuff that you would be doing if you were an astrophysicist. For those of you who are just interested in the subject, I hope this helps you all keep up to date with exactly the key problems that astrophysicists are tussling with at this very moment. So, why is this an interesting question? Why do people look at or research gas depletion? Well, gas depletion is an interesting topic for astrophysicists because gas in galaxies and clusters of galaxies are the star-forming mechanism. So stars are basically balls of gas that under the influence of gravity start a chain reaction of nuclear fusion, start to burn, and that is your stars. So if gas is being depleted from a galaxy, what that means is that the galaxy would no longer be able to form stars. A study of how galaxies form stars, the amount of gas and the star formation rate is a very important input to our cosmological models, the models that devise how the universe evolved from the Big Bang up until now, because those models make certain predictions about how much gas should be in galaxies and therefore what kind of star formation rate you should see. So this effectively is the observation part, looking through telescopes to see what that star formation looks like, how much gas is there, and therefore are our cosmological models correct? Right, so let's break it down exactly what they looked at, and I'll explain some of the concepts as I go along. The first thing they did was they basically looked at 6 galaxies at what they call high redshift. This means that they looked at 6 galaxies that are relatively far away. Before I move on, let me quickly explain what the concept of redshift is. If you want to study astrophysics or cosmology, redshift is the fundamental concept you need to understand, because redshift is the way that astrophysicists measure distance. We don't talk in terms of miles or kilometers or meters, we talk in terms of redshift. What is redshift? Well, you're probably all familiar with the Doppler effect. For example, when you hear a siren from an ambulance or a police car, it changes its frequency and wavelength as it's coming towards you versus when it's going away from you. This is from the contraction and stretching of that sound wave. Redshift in light is a very similar concept insofar as the wavelength of the light is being increased, i.e. shifted towards the red end of the spectrum, red shift. Why is the wavelength of the light being increased? Well, we know ever since Edwin Hubble's day that the universe is expanding. So what's actually happening to light waves as they travel through the universe is that the space itself is being stretched. And as the space stretches, so does the wavelength of that light. In other words, the further away a galaxy is, the more stretching that will have gone on as that light travels towards us, and therefore the more redshift, the greater the shift towards the red end of the spectrum you'll see in that light. And therefore, further away objects have higher redshifts. And that is the cosmological distance scales that astrophysicists use. In this piece of research, they looked at high redshift galaxies, so galaxies that are quite far away. They do this because faraway galaxies help you probe earlier in the universe, because light takes a long time to reach us for galaxies that are many thousands of light years away, perhaps. What you're effectively doing by looking at those galaxies is casting back in time, looking at the universe at an earlier state. So that's why they're choosing high redshift galaxies. Effectively, they're doing a little bit of time travel. And what they're going to do is they're going to look at the star formation in those galaxies, i.e. the star formation in the relatively early universe. So what these scientists then did is they looked at the emission spectrum of these galaxies. They looked at light, the intensity of light emitted in various wavebands, and that will help you, of course, measure how many stars or how much star formation is going on in these galaxies. What they found is that for the majority of these galaxies, the star formation rate was less than 0.1 solar masses per year. In other words, a extremely small. In astrophysics, we call such galaxies quiescent. In English, that term simply means they're not forming any stars, they're quiet. That would come from a lack of gas in those galaxies in order to form those stars. But here's the puzzle, and the thing that they were really looking at, is that most cosmological models predict that in the early universe, galaxies should have lots of gas. Why is that? Well, the galaxies are basically sinks of gravitational energy. They should put all that gas in, that gas should fall into those galaxies, be crunched up, and then form your stars. So one would expect early universe galaxies to have lots of gas, and therefore high star formation rates. So the key question the astrophysicists were looking at here is, well, why do we have these faraway galaxies where star formation has already died? Now, it can't be because all the gas has been used up. As I said, these are early universe galaxies, galaxies far, far away, to coin a Star Wars phrase. They shouldn't have had the time to use up all of their gas yet. So something else is happening. It's not that star formation is finished because the gas is used up. There must be another process going on here that deprives the galaxy of the gas it requires to make stars. So the conundrum is, what is causing this gas to be blown away from these galaxies? Well, this is where our old friend, the supermassive black hole, comes in. Now, you may remember from an earlier video that the centre of most galaxies are populated by a supermassive black hole. Supermassive means basically they're millions and billions of times the mass of our Sun. Effectively, the galaxy, the stars in the galaxies orbit around this central gravitational force produced by this massive, huge black hole. What happens is, if the black hole, now of course the black hole you can't actually see, but let's assume that it looks like a black dot. What happens is that the gas will come into the galaxy. It will have some angular momentum as it comes in, and that angular momentum will cause it to orbit around the black hole. What will happen is the black hole will form what's known as an accretion disk of gas that's basically circling around it. This will fall into the gravitational potential well as it orbits around the black hole. Effectively, it will heat up. Through friction and the gain of gravitational potential energy, this gas will heat up and produce a lot of radiation. It is that radiation that can blow away the cool gas in that galaxy. And as that cool gas is blown away, that is exactly the gas that's required to form stars. So it is thought that what are called energetic winds coming from supermassive black holes are things that can blow away cold gas and therefore shut down star formation in early universe galaxies. And that is one potential explanation for this result. The main conclusion of this paper is that in certain high redshift or far away galaxies, early universe galaxies, there's very limited star formation. The reason there is limited star formation from these observations is from a depletion of the cold gas required to form stars. Why is that cold gas depleted? Well, the thought is that it's blown out of the galaxy by winds caused from supermassive black holes. The significance of this result, how does it influence your practical daily life? I'm going to be honest and say that it doesn't. But this is what we do as scientists. We try and explain the natural world around us. I put a link to the paper at the bottom. I've also put a link to something that is equally interesting that I will discuss maybe at a different time, and that's one of our universe simulation models. It's been around for a long time. It was developed first in, I think, the Max Planck Institute. And this is basically a computer simulation of the universe right from the very beginning all the way up to the present day. And when I talk about comparing observational results to models, that's what I mean. You can use Einstein's general relativity equations, put it into a supercomputer, and basically map out the formation of the universe. And that's where the predictions, the theoretical predictions, come from that we compare the observational models against.